Hello everyone, I am Karthik Urju. Today I will be presenting our internal test analysis covering question 7 and 8. This section focuses on median approximation and similarity analysis. This presentation is submitted to Dr. Shaligram Prajapati. Moving on to our first slide, the median problem. Let's start with question 7. We are asked to propose methods for finding the median in massive datasets, what we call big data. The core problem here is computational cost. Finding an exact median typically requires sorting the entire list of numbers for millions or billions of records. This sorting process has a complexity of big O of n log n, which is too slow and memory intensive for real-time applications. The proposed solutions are binning. We group scores into buckets like 0 to 10, 11 to 20 and simply identify which bucket contains the middle value. This is extremely efficient. Second one is random sampling. We pick a small random subset, say 1000 students, and calculate the median of that sample. It's fast, big O of k log k, but it is just an estimate. One pass algorithm. Advanced method like t-digest scan the data only once to build a sketch of the distribution. This offers the best balance of speed and accuracy. Moving on to the next question, we face a common data science task, similarity search. We have a new student query which with specific feedback score 1.1 for faculty responsiveness and 1.6 for infrastructure support. We need to compare this query against 5 existing students, S1 through S5, to find who is most similar to this new profile. Uh, Euclidean distance calculation. To do this, we calculate the Euclidean distance, which is a standard straight line distance between points. For student 1, for student S1, the difference were very small, 0.1 and 0.1. Squaring this and taking the square root gave us a distance of 0.141. For student S4, the difference was slightly larger, 0.2 and 0.1, resulting in a distance of 0.224. Since a smaller distance means higher similarity, S1 appears to be the closest match so far. Euclidean ranking. Here are the final ranking based on our calculations. Student 1 is the closest match with a distance of 0.141. Student 4 is second. Student third is third. Student 2 is the least similar with a distance of 0.671. This ranking helps us instantly identify which existing profile matches our new query. Other similarity measures are Manhattan distance. This sums the absolute difference. For S1, this is the simply 0.1 plus 0.1, which is 0.2. Superminimum distance. This looks at the maximum difference in a single dimension. For S1, the max difference is 0.1. Even with these different methods, student S1 remains the closest match, confirming our result. Next, cosine similarity. Finally, we considered cosine similarity. Unlike the previous method that measured distance or magnitude, cosine similarity measures the angle between the vectors. This is particularly useful if we care about the pattern or ratios of the feedback. Example, is the student consistently positive rather than the absolute number? Key takeaways. Key takeaways of median approximation. Finding an exact median is often too costly for big data. We must trade off accuracy for efficiency using methods like binning or one-pass algorithm. These techniques are essential for scalable data systems. Key takeaways for similarity analysis. Metrics like Euclidean, Manhattan, and Superman distance quantify similarity in different ways. Context is the key. If magnitude matters like exact score, use Euclidean. If orientation matters like preference pattern, use cosine similarity. Thank you for your time.